Okay, everybody. Yesterday we talked about the difference between rational and irrational numbers. Today we're talking about decimal approximations of irrational numbers. And basically what that means is a decimal approximation is a decimal that gets close to the irrational number. It's the best way we can estimate or say the number that it's about, right? So if you want to write in your notes, approximation equals about or approximately. That would be a really good thing to write down, because approximations is kind of a loaded word, but I wanted to say it because it's the best math word that we have to talk about it. Okay, so let's talk about, in the rest of this video, 1, how to know what your decimal approximations are, and 2, how to use them. Okay, here we go. Okay, so if you remember yesterday, we talked about pi as a decimal, or even some in class today, being 3.14159 ... Okay, well that is the beginning of the decimal, but that's not the whole thing. So the reason we have decimal approximations is so that we can make the number a little bit more easy to handle and think about. So I'm going to say, for the simplicity of our lesson, let's round to the nearest tenths place, okay? So when we say pi equals 3.14159 ... we can also say it's approximately, this is the symbol for approximately, that means this number is about this much. It doesn't exactly equal this much, but it's about this much. Remember our rounding rules. If we're rounding to the nearest tenth, we gotta look at the hundredths place, and it tells us what to do with the tenths place. So since our 4 is below 5, that's going to tell us to stay the same. So we're going to say pi is approximately 3.1. So that's the decimal approximation for pi. I know a lot of times we talk about 3.14 being pi, and that's still a great number to use most of the time, but just for the sake of this lesson, we're going in tenths. Anytime in the future when you make decimal approximations, right, when you use numbers that are about equal to irrational numbers, always follow the directions. So if they say to round to the nearest thousandth, you better round to the nearest thousandth. If they say hundredth, round to the nearest hundredth. Since I'm saying tenth, you can round to the nearest tenth, okay? Now let's look at the square root of 2. I'm going to put this in my calculator because I don't have this memorized. Square root of 2 equals, okay, so I'll give you the first 5 numbers after the decimal point that I get. 1.41421. Okay, now I'm looking at the hundredths place. It's going to tell me what to do with the tenths place, and that's going to be, whoops, I got to use my approximately symbol because it doesn't equal 1.4. It's about 1.4, right? Okay, now square root of 3, again, I'm putting that in on my calculator. Square root of 3, you may use calculators on your decimal approximations lesson. It equals 1.73205 ... which is approximately, again, looking at the hundredths place, it's saying stay the same, so 1.7. Okay, last one, I wanted to do an even bigger square root. Square root of 57 equals 7.54983 ... which is approximately, we're going to look at our numbers here. 4 tells us to stay with the 5. All of those tell us to stay. That's interesting. So we're going to say it's approximately 7.5. Okay, so that's how you create decimal approximations. Now let's talk about how you use them. All right, I don't know if you can hear the chaos out in the hallway, but there are a lot of people out there, so I'm going to hopefully not have you be distracted by that. But here we go. Last thing we're going to do, we're going to apply these decimal approximations. So we said on the last page that pi, our decimal approximation, is 3.1, right? Okay, what about the square root of 10? If I put the square root of 10 into my calculator, I get 3.16 0.27. Okay, now, when we approximate that, we get rounding 3.2. So which one, now my question is which one is larger? This is how we're going to apply this. Which one is larger, pi or the square root of 10? If their decimal approximation is 3.1 and 3.2, which one's larger? Well, it would be square root of 10. So we're going to say square root of 10 is larger. Now, next thing I want to talk about is, pi over 2. Not only do we have to talk about what the decimal approximation is, we also have to talk about the fact that, wait a second, you have pi in a fraction. You said that rational numbers could be written as fractions. But remember, I also said there were exceptions, and here's one of the exceptions. If you have an irrational number, something we've already determined is irrational, like pi, if you have that in a fraction, like we do right here, pi over 2, irrational in a fraction, that whole fraction now is irrational, okay? So pi over 2 is technically an irrational number even though it's written as a fraction. That's the only exception to the rule, is if there's an irrational number in a fraction, it is not rational, okay? The biggest thing is if the decimal never ends and never repeats, irrational, okay? So now, let's talk about this decimal approximation. We have pi, oh goodness, where's pi in my calculator? I'm using one of these ones. Oh, there it is. Shift pi divided by 2 equals, okay? Here's my decimal approximation numbers, 1.57079, ... Okay, so my approximation is going to be 1.6, right? Because the 7 tells me to round the 5 up. What about the square root of 3? Square root of 3 is 1.73205. And the decimal approximation for that is 1.7, right? Approximately. Okay, now which one's bigger? Pi over 2 is approximately 1.6. Right down here, we see that. And square root of 3 is approximately 1.7. So square root of 3, again, this side is going to be bigger. Okay? So that's essentially what we're doing, is we are finding the decimal approximations, meaning we're going to find a decimal, round it to the nearest tenth, and then we are going to compare them. Which one's bigger based on the decimal approximations. Okay? So make sure you've taken notes on this, that you bring them to class tomorrow, and that you are prepared to talk about decimal approximations. All right, see you tomorrow.